Hey everyone, my name is Frankie. I'm going to be giving you guys a little crash course on resonance. I know when I took this class for the first time, resonance I didn't really grasp it fully in the beginning, and it totally affected me later in the semester. So hopefully if you're struggling a little bit or just need a little refresher, this helps you out. And we're going to start by going over a couple rules to keep in mind when coming up with your contributors. So the first one is only delocalized electrons can move. So what I mean by a delocalized electron is electrons not pertinent to a single atom. So lone pairs and double bonds, and only electrons. So we're not moving any atoms or nuclei, and we are not breaking sigma bonds. Another rule to keep in mind is the overall charge must remain the same, and this is kind of hard to explain, so I have an example to show. Right here we have the nitrate molecule, and you can see that there is an overall negative charge. There's two charged negatively charged oxygen and one nitrogen, and this resonance also has to have those two negatives and a positive, or hypothetically it could have one negative because the formal charge is negative, but that's the idea. And then another example would be this propanone right here. So we have a neutral charge in the given, and then the resonance contributor has a positive and negative, and this does work because they both kind of neutralize each other, almost kind of cancel out, but the overall charge is neutral in that one. Oop, this is okay. And then some tips to keep in mind is to be mindful of the octet rule, so we're not making 5 bonds on carbons and violating that. And then last one would be in relation to like the major and minor contributors. So the most complete octet is the stronger contributor. So the one with the least amount of charges, we have most of our shells filled up. That's going to be our major, the most stable. And I have a couple examples. So this molecule right here, we have a carbocation, so a positive charge on the carbon, and then we also have another lone pair on the nitrogen, so we have a positive and negative charge, overall neutral. So keep that in mind when we're coming up with our resonance. So we're going to look at the most electron dense area that we have here, which would be this negatively charged nitrogen, and the only place we can really take them is making a bond right here. Now this isn't violating any octets because we have the positive charge on this carbon, so we're kind of filling it up. So this is okay with 4 bonds here, and then we're all set with this nitrogen. And can we move? We're checking if we can see moving anywhere else, any other electrons. So we do have an implied lone pair on this nitrogen. We cannot move it here, so let's say we did. Then we have 5 bonds on this carbon here, and we can't really move them anywhere. So this is a no-go, and then same with this double bond here, no-go. So then our contributor we get from this is right here. So the charge is still neutral here, and we're not breaking any octet rules. Everything is a-okay. And now we can look at the major and minor. So let's see, the most complete octet would definitely be this one. There's not a lot of charges. It's the most stable. So then we can say this would be the major contributor, and this would be the minor. So you would likely see a configuration like this in this molecule, more so than this one. Another example, make sure we can see this, would be this molecule right here. So we can see we have a negatively charged carbon and a double bond on this oxygen. And remember, we do have these implied lone pairs. So we start in the electron dense area, and we have this negatively charged carbon. So we can move these either here or here. If we move them here, we would be making 5 bonds on this carbon here. So let's see if we could do here, and we would be violating 5 bonds on this carbon, but we can make a bond and break a bond. So now everything is all right. We kind of just bump the electrons up, and then the resonance contributor where we would get from this would look something like this, and then 1 bond, 3 lone pairs on this oxygen, giving it a negative charge, and then that carbon is all set. So when we're looking at the major and minor contributors of here, they both do have this one negative charge, so they're not neutral, but we can look at where the negative charge is. This one, it's on a carbon, and carbon does not like to have a negative charge. It doesn't hold it well, but as we all know, oxygen does hold a negative charge well, so this would be our major contributor because it is more stable than a negative carbon. So hopefully this did help you guys out a little bit, like maybe a little refresher. Hang in there. Good luck. It will get easier if you stay on task. Good luck.